Today I'm joined by Marco Talo, who is one of our meteorologists here at Meteomatics, and we're going to be talking about historical weather data. What kind of past weather data are there? What kinds of past weather data can people use?
Yes, so there are many different types of historical weather data. The first data source for historical data are station data. So it's maybe the first thing that comes up to your mind when you think about historical data, which has actually been recorded and measured, and where long time series are available for certain weather stations. Then there are sources like radar or satellite data, which can give you a precise image of precipitation events, for example. So this is really variable and different across the globe, so it depends on country, on political situations. It's really unevenly distributed across the globe. If you think of Africa, for example, or also South America, the distribution is quite different.
So far we've talked about ground-based stations and also radar, and you say that both of those are observational data sources.
Yes.
So what kind of data exists if it's not observational?
Model data or reanalysis data. There are two types of model data: historical forecasts, which actually give you the forecast that has been generated in the past for the upcoming days, and there is reanalysis data.
Okay.
And reanalysis data is a blend of model data and historical observations. So all the possible data sources that are available are collected. So satellite images are used, station data is used, radar data is used, and all this information is gathered and assimilated in the model. And the base model for this is the short-range forecast from the operational forecast model. And reanalysis data also has the advantage that it's a very consistent data set.
Okay.
So in space and time around the globe, because it's the same procedure how it was generated for the whole time period.
So, historical observations, historical forecasts, and reanalyses. Those are kind of the three different types of historical data we've talked about so far. How easy is it to get hold of data from those different sources? Where do you get it?
Okay, so basically it's not that easy for people to get these types of data. So maybe I'll start with station data.
Sure.
So, like I said, it depends on countries, and of course, it also depends on the country how easy you can get them.
Okay.
There are possibilities to purchase station measurements, and some countries even offer it for free.
Yeah.
This is also possible. And or countries just provide a limited set of stations to the public and show this on their website or forecasting site or whatever. So usually when you get these station data, then you get it for the entire country from the National Weather Service.
So where do we find historical forecasts?
So from the huge computational centers like the ECMWF, there you can get such historical forecast data, or you collect the current operational forecasts continuously and create your own historical forecast database, so to say. And also reanalysis data can be obtained from such computational centers. You do not get data for the entire globe, so the data is split into pieces across the globe, and you need to connect all the pieces to get the global image if you're interested in that. Data formats and also the spatial coverage in the files can be really challenging without any programming knowledge. Yes, so what we do or what we offer through our API is basically one big advantage. You can get the data through one single endpoint through our API, and you can get it for any coordinate on the globe. So what we do in the background is we fetch all the different tiles from reanalysis data, for example, or from the operational forecast runs, and we stitch that everything together to generate a picture for the entire globe. And we interpolate between grid points in the models so that you can really access any coordinate on the globe. And we do another thing that's really beneficial for the quality. So the native data that we ingest in our API for the operational forecasts is 7 kilometers, and for reanalysis data it's 19 kilometers. And what we do in the post-processing procedures is a so-called downscaling. And that means that we achieve a final resolution of even 90 meters. And we can do that by applying a digital terrain model that has a resolution of 90 meters. And then we can downscale the surface parameters like temperature, relative humidity, and really reflect reality by using the model data as input with the native resolution. So it's possible to query any random coordinate. And when talking about resolution, I quickly continue with temporal resolution, and we also do interpolation techniques there. So you're not forced to use the native resolution from the model, for example 1 hour. You can also get the time steps in between from the API due to interpolation techniques. So you're completely flexible in time and space. Yeah. So you can either enter latitudes or longitudes, or you use zip codes. So everything is possible.
Okay, cool. Well, thank you very much for joining me today, Marco. It's been an absolute
Thank you.
pleasure.
Yeah.
And I'll speak to you again soon.
Yeah, see you soon.